This is AQA GCSE Chemistry. It's the bonding topic, which is dual award and triple award. And we're now on video number 6, where we're going to start to look at simple covalent molecules. As always, I'm going to recommend that you pause the video on the activities, try them for yourself, and then you get to see how you've done. So within this one, we are going to look at how we can use dot cross diagrams and other forms of modelling to show molecules or giant structures. We're going to look at why simple molecules have low melting and boiling points, and we're going to see why they do or do not conduct electricity. And the first question here, what is a covalent bond? So a straightforward definition question. And what we're looking for here is that it's a shared pair of electrons. That's a really important definition to learn. First of all, because you might be asked it directly, but second, because you need to understand that it's the attraction between that pair of electrons and the positive nuclei on either side of them that actually holds that molecule together. So we've got here 5 different representations of the methane molecule. And there are no right or wrong answers on this one really, but I think it is important that you are able to articulate what's good and what might be quite limiting about models within science. And on here, if we take a look at some of the options, we have got our dot cross, which shows the pair of electrons. That's the covalent bond between this carbon and this hydrogen. We've also got that here, but what we've not done is drawn the circles out. So you might have thoughts on whether you would prefer the circles so you can see the shared area more clearly. Would it be more complicated if this had more electrons on the outside, if this was CLs, for example? Which would you rather do? What would be most effective to show what you know within an exam? And we've also got some examples where we're representing our covalent bond with a straightforward stick. And we know in a covalent bond structure that the stick means one shared pair of electrons. Now that means when it comes to drawing a double bond, that would mean 2 pairs of electrons between, for example, a C and a C in an alkene. The big difference between these two is that we're drawing circles around the atoms. So it's again about whether that's advantageous. Does it just take up more time? Is this clear enough? And generally, of the ones that we're going to do at GCSE, this one with the circles and this one with the sticks are what you will see most commonly. The final one, the 3D ball and stick model, we've got a line coming out of the paper and a dotted line to represent going into the paper. And that simply shows that these are not 2-dimensional structures. This is 3-dimensional in space. Not hugely important at GCSE, but it is something that's worth being aware of. So now let's go on and let's have a look at melting points of, we've got some examples here, water, carbon dioxide and methane. Now, in this, what I'm hoping you're seeing is that carbon dioxide and methane are gases at room temperature. Water is a liquid, but we've seen many giant covalent and ionic substances and metallic substances that are solid at room temperature. That tells us that simple molecules, simple covalent substances have low melting points. But why? Well, in this topic, it's all about using the right terminology. When we melt water or carbon dioxide or methane, we are not breaking bonds. We don't break the OH bond within water. What we do is overcome the weak intermolecular forces. 2 key points here. Intermolecular forces, forces between molecules, and I'll show you an example of that in a moment. But intermolecular forces are always weak. Now, if that's the case, not much energy is needed to overcome them. And just to illustrate what we mean by an intermolecular force, I've done a dotted line here between one carbon dioxide molecule and another carbon dioxide molecule. It's this that's overcome. We're moving the CO2s apart. We are not breaking down the CO2. So now let's move on and look at conduction of electricity. Does carbon dioxide, does methane, does water conduct electricity? And no, they do not. And the reason for that is that there are no free electrons. And that means that we can carry charge through the structure. So we've spoken in, depending on which order you're watching these videos, in metals, the electrons are delocalized and can carry charge through the structure. In an ionic compound, when aqueous or molten, the ions are free to move and carry charge through the structure. In a simple covalent molecule, there are no free electrons, so we can't carry charge through the structure. Now, in terms of the demonstration, you may have seen the video where we looked at salt trying to conduct electricity, and as we added water, the bulb lights. The same would not happen with sugar, and that's because sugar is a covalent molecule. It doesn't break down into ions, so we are not going to get that conduction of electricity. And that's something that can illustrate quite neatly what we're trying to look at in this video. That takes us to the end of this video. Thank you for listening, and goodbye.